Okay, so here we have a limit, and it says we should use Lopi. Right away, when you see x's in the base and the power, let me just be clear. When you have x's in the base and x in the power, both places, you're going to L in both sides. That's just pretty much how we always handle that. So you can plug in right now if you want. It's not going to go anywhere. Plug in a zero there. We're going to zero from the right. Plug in a zero there. Be one plus the sine zero. One plus sine zero is zero to the one over zero, right? So that's going to be one. What's one over zero? Infinity. Remember that? Anything over zero, like if you take a number and you divide by zero, that's infinity because the bottom goes into the top. So 7 over zero, 1 over zero, whatever, they're all infinity. So this is 1 to the infinity. Now you might say, well, that's 1. 1 to any power is 1. Well, it's not really 1, right? A zero is just, sorry, x is just getting close to 0. It's not right on 0. That means this is getting close to the sign of something close to 0 is close to 0 itself. Plus 1 is close to 1, but it's a little bigger than 1. It's not exactly 1. And this is infinity. So it's something a little bigger than 1, getting really close to 1. So if it's bigger than 1, you raise to infinity. So it's just unclear. It's an indeterminate form. We can't tell. It's rules in conflict. You smell when I'm stepping in there, right? Because one, you might think one to any power is just one. Yeah, but it's not really a one. It's just close to one. You think, well, yeah, one plus zero is one. No, this isn't really zero. This is just close to zero because x is getting close to zero. It's not exactly zero. It's just a little bigger than one. And this is really, really big. So maybe it's a number, maybe it's one, who knows? It's indeterminate. We got to change them up. You know what we got to do? Because they say Lopi. They say Lopi up here. What is that? What do we always know we need to do when they say use Lopi? We got to get it to be 0 over 0 or infinity over infinity. That's the requirement. Then once you get it in that form, then you're allowed to take the derivative of the top and the bottom separately. Separately being the key word. Not quotient rule, but separate derivatives. So I got to get it to be 0 over 0 or infinity over infinity. All right. So, and I know I'm going to have to do ln of both sides because that's what you do when you have x's in the base and the power. Okay. So with those pieces of information, I'm going to go, all right. Let's say y equals, I'm just going to go, I won't put the limit in yet. Bring the limit in a second. Okay. So then I'm going to go, okay. I got it. I'm going to have to ln, let's bring it down to the next line, ln both sides. Okay, then why? It allows powers to come in. That's why whenever we have x's in the base and the power, we always on both sides because of that great quality that powers can come down to the front of the log. So I go, oh, so then ln y. Now remember, this is ln y, no longer y, no longer the original problem, but ln of the original problem. So at the very end, we're going to get rid of that ln by e in both sides, right? That e is the opposite of ln, cancels out. Whatever we do to one side, do to the other. So whatever we get, it's going to be e to that. All right, anyway, so the 1 over x comes down front. ln 1 plus sine 7x, okay? So now we remember, all right, so that's looking good, but we're really trying to do the derivative, the limit here, right? So let's stick that limit back in front now. Just gonna work with this side here. I'll take the limit, x goes to 0 from the right, of this thing. Well, if I do that, if I plug in 0 there, let me do it smaller. If I plug in 0 there and 0 there, what is 1 over 0? Well, that's infinity, as we talked about. 0 on the bottom goes into 1. 0 goes into 1. The bottom goes into the top, goes into 1 forever. Times ln of what? 1, because the sine of 7 times 0, sine of 0 is 0. Check it on, not sure here. Let me show you. Check it on Desmos. Boom. So I can go sine of 0. See, it's 0. All right, back to it. So we've got sine of 0 says ln 1. And what's the ln of 1? As we said, ln 1 is 0. That was just on the screen. Did you see it? ln of 1, I'll put it down here. Go to functions, find ln, back to it, ln of 1 is 0. Getting a bunch of zeros here. Okay, so what? So then this means it's infinity times 0. that also is indeterminate. We don't know what that is. We cannot determine. It's unclear. Why? You know, anything times zero, zero. Yeah, it's not really zero though. It's just close to zero because x is close to zero. So this is close to zero. So one plus something close to zero is close to one, which makes this close to zero. It's just close. It's just a really tiny number. This is infinity. So really tiny, really big. What is it? We don't know. But so we know what we need to do. We need to change it because Lopi says you got to have zero over zero. I think, oh, just grab this guy and move it to the bottom, right? That's what we always do. You getting the hang of this? So then we go, okay, I got you. I'm on to your games. We say this is going to be sine. Then we take this 1 over x and we go, you're down there, buddy, and you're x over 1. So remember, whenever you flip something to the bottom, it goes upside down because dividing is upside down multiplying. You know that, right? I've shown it a few times. Take 10 divided by 2. We all know it's 5. That's the same thing as 10 times a half, still 5. Multiplying by the upside down is the same thing as dividing. So when you're multiplying by 1 over x, divide by x over 1, it's the same thing. Okay, why is that so great? Why do we want to do that? Why is that so great? Well, because now we'll get Lopi form. What do I mean? Put a 0 in there now, put a 0 in there now. What is that? Well, it's ln of 1 plus 0 over 0 over 1, right? And that's ln of 1. And that's 0 over 1 is just 0. ln of 1 is 0. It's 0 over 0, Lopi. Lopi time. Whenever we get 0 over 0, we get Lopi. So I'm going to say, so now we can use Lopi. So I'm going to say now, so we had to rearrange it. See how we always do that? We took ln to both sides, brought the power down, so what we always do, we got x's in the base and power. And then we had to rearrange it so it was coming out 0 over 0. Because that's a requirement of Lopi. It says don't be doing the Lopi rule unless you get 0 over 0, infinity, infinity. We rearranged it. We took that 1 over x, flipped it to the bottom, x over 1. Because it was infinity times 0, that's no good. Grab that, flip it to the bottom. Plug it in again. Now it's 0 over 0, and that's green light. Lopi, drive your car. The light is green. You go through that intersection. So now it's Lopi time. We get 0 over 0. So what does that mean I can do? Derivative of the top and the bottom separately. Not chain rule. Easier than that. Just separate, two totally separate derivatives, right? So I'm going to do just the top all by itself. How do you do the derivative of natural log of anything? Well, it's 1 over that thing, 1 over the argument, times the derivative of the argument. What's the derivative of the inside? Well, one's not going to do anything. Derivative of sine is cosine. Keep the inside the same at first, times the derivative of the inside. Chain rule, 7. Now, what's the derivative of the bottom? Well, this is just, it's a fancy x. The derivative of x is 1. Put that limit back in the front. So I notice what I did there. I did not do chain. I did not do quotient rule, right? I didn't, quotient rules, they take turns, divide by the denominator squared. I hate the quotient rule. I try to avoid it when I can. This was Lopi, which means what? Now, normally we put an H here saying we just did L'Hopital's rule to equal this thing. Meaning what? Derivative of the top separately, bottom separately. That's it. Once each separately, that's all. That's the beauty of Lopi. You can do that when you get 0 over 0. You know, what's so great about that? Well, now watch what'll happen when we plug in that 0 again. Let me clean it just a tad bit. We're basically there. So this 1 on the bottom, we'll leave that. So what do we have? This guy's over 1 over 1. So they're just going to go to the top. So I'm going to go, okay. I'm going to have 7 cosine 7x over 1 plus sine 7. Like I said, I don't need that 1 on the bottom. That's gone, right? So what's that then? Now plug in your 0. 0 in, 0. So x is still going to 0. So we'll get 7 cosine 0. What's cosine 0? It's 1. I'll show you on Desmos here. Cosine 0, bingo, 1. Cosine 0 is 1. So this is 7 times 1. 7 times 1 over 1 plus sine of 0 is 0, as we talked about. So we go, oh, that's just 7 over 1. That's just 7. We're done. The answer is 7. No, careful. Careful. Remember, this is ln y. Probably I should probably bring that down. ln y. ln y. So now we're going, okay, so ln y is 7. Right. And what's the final step? E both sides. Cancels that out. Y is E. Remember, you're always going to have to finish up like that when you ln both sides. Your last step is you're going to e both sides, which is the opposite. It undoes the ln. E's and ln's are opposites. E to the seventh. There's our answer.